Alright, number 63 from the Exponent Handout. Just to let you know, I would never put a question like this on a test or exam. It's too long, and chances are most people would not get the correct answer, but it's still a good question to try at home. Alright, let's see. I'm going to start with this fraction, and I cannot factor the negative ones out of those. That's not something I can do. The only thing I can do is write this as 1 over a plus 1 over b over 1 over a minus 1 over b. Can't cancel, can't do anything like that. This is the only thing that you can do. The second fraction is a similar story. Nothing can cancel there. You can only cancel factors, and those things are added and subtracted from each other. So all I can do is write a to the minus 2 is 1 over a squared. Then I'll have 1 over b squared. And then I'll have 1 over a squared plus 1 over b squared. And now over here, definitely want to be following the order of operations on this fraction. So what I'm going to do is do the work in the brackets first. So the only thing I can really do in the brackets is to get a common denominator. So I'm going to multiply this by a over a. So I'll have a plus b over a. And I'm going to do the same thing to the second bracket. So I'll multiply this by b over b. And this will be b plus a over b. So why don't we erase that and write it as a plus b, put it in alphabetical order. Alright. Going back to the beginning again, what can I do next here? Still can't cancel anything, but I can get a common denominator for the complex fraction for the numerator. So my denominator will be ab, and this will be multiplied by b over b, this will be multiplied by a over a. So I'm going to have b plus a over ab. So I'll write that as a plus b, put it in alphabetical order. And in the denominator here, same idea. I'm going to have ab as my LCD. So this will be multiplied by b, b, a. So here is going to be b minus a over ab. Second group of terms here are fractions. Same sort of idea, complex fractions. I'm going to have a squared b squared for my LCD, multiplied by b squared over b squared, a squared over a squared. So I'll have b squared minus a squared over ab squared. The second bunch, LCD a squared b squared. I'm going to get a common denominator here by multiplying by b squared over b squared, a squared over a squared. So I'm going to have b squared plus a squared, or maybe people put it in alphabetical order, a squared plus b squared. Alright. What can I do with this last section? Well, the negative here, I can flip over that fraction, so I'm going to have a over a plus b squared. And the same thing with the second fraction. The negative allows me to flip that over. And then on the next step I'll do the actual squaring. Alright, let's see. Now this complex fraction, I'll keep the numerator as it is. So that numerator, and I'll multiply by the reciprocal of the denominator. And what's going to happen is they're going to cancel. Same idea here, b squared minus a squared over a squared b squared multiplied by the reciprocal. And those are going to cancel. And I'm going to apply that square and square both of those fractions. So I'm going to have a squared over a plus b squared plus b squared over a plus b squared. Back to the beginning. So this is a plus b over b minus a multiplied by b squared minus a squared over a squared plus b squared. So that's from this group. Now the last group, again it's a complex fraction, so I'm going to combine the denominators there together. So they actually already have a common denominator. So that's going to be a squared plus b squared all over a plus b squared. Now if you FOIL that out, I can see why you might try that, but when you have these nice little packages, you just want to leave them unless you're forced to FOIL it out. So let's see. So I'm just going to leave the first and the second fractions. Well, the first one as it is. The second one, I notice that I have difference of squares there, so I am going to factor that. B plus a, b minus a. And nothing I can do in the denominator. And this fraction, I would take 1 and multiply it by the reciprocal of this denominator. So I'll just do that on the side. 1 times a plus b squared over a squared plus b squared. So I'll put that right here. Lovely. So now, since everything's multiplied, if we have any common factors in the numerator and the denominator, we should be able to factor them out or cancel them out. So I see this and this, and that's about it. So here I have a plus b, here I have a plus b, and there I have a plus b squared. So that would actually turn out to be a plus b to the 4th. And then here I've got a squared plus b squared and another a squared plus b squared. So now I'm going to check the solution. It's a little hard to see that. So the solution, a plus b to the 4th, a plus b to the 4th, and then over a squared plus b squared squared, a squared plus b squared squared. So if you're not getting that, things that I would check. Have you canceled stuff within sums and differences? Have you done that? Did you expand something maybe when you could have just left it as a nice little package? Did you see this as difference of squares? Hopefully that helps. If not, let me know. I'll see what else I can do for you.